Here we go. All right, so far we have taught you two different ways to solve mole problems. One was dimensional analysis that you weren't really happy about. The second one was the railroad method, and I think for a lot of you that works great. Here's the third way to do it, and this is absolutely, positively the easiest way on the planet. One of the skills that you come to chemistry with is the ability to use a ratio and solve by cross-multiplying. You people are pros at that. So based on your incredible skill, we devised a method that will solve these problems and probably make your life really easy. So we're going to use ratios to solve these problems. But in order to use the ratios, you need to remember mole facts. Okay, here we go. Here are your mole facts. And you probably already know this. 1 mole is equivalent to 6.02 times 10 to the 23rd atoms. Where did we get this number from? Did we just pluck it out of the air?
Yes.
Avogadro.
Avogadro's number. Thank you very much. 1 mole is equal to 6.02 times 10 to the 23rd particles. 1 mole is equal to 6.02 times 10 to the 23rd molecules. 1 mole, you can add this one, is equal to 6.02 times 10 to the 23rd. You're ready for this now. You've learned this. Ions. All right. All of these things, ions, atoms, particles, and molecules, all belong with Avogadro's number. All of them are equal to 1 mole. Now, 1 mole is also equal to the molar mass, and I want you to write the word grams in here, from the periodic table. And 1 mole is equal to 22.4 liters of any gas at standard conditions. Standard temperature and pressure, STP. Okay, let's look at the periodic table really quickly. If I wanted to know the molar mass of NO, this is what I would do. I would list the atoms that I see. I see an N and I see an O. Then I would count them. I see 1 N. How do I know there's 1 N?
Because it's a capital letter.
Well, because I can identify,
yeah.
Yep, there it is, right there. It's an element. The subscript 1 isn't written there, but it belongs there. Chemists are lazy. They never write the number 1. How many oxygens are there?
1.
1. Then I'm going to look for this number on the periodic table. And I'm going to write it in here. What is this, 14?
14.007.
And I'm going to round it because I'm not going to use all the significant figures. I don't know. I don't need to. Then I'm going to multiply. 1 times 14 is equal to
14.
1 times 16 is
16.
equal to. And then I'm going to do it with 14
30.
and 16.
Add
I'm going to add them up. So the molar mass of NO is 30 grams in 1 mole. There we go. Got that?
Mm-hmm.
Done. Okay. So, we were looking at that and thinking, boy, that's a lot of stuff to list all the time. So we decided to just write it out like this. So 1 mole is equal to 6.02 times 10 to the 23rd atoms. Ions, particles, or molecules. 1 mole is equal to the molar mass in grams. 1 mole is equal to 22.4 liters of gas. This is so important, you should highlight it.
What if you don't have a highlighter?
You should have gotten one when you walked in the door. But now you're just going to borrow somebody else's because you'll get in the way of the camera. Do not make your hand accessible. Okay, now pay attention to this because this is a new twist. Here's the new twist. 6.02 times 10 to the 23rd atoms is mathematically equal to 22.4 liters of gas. Do you see that? The molar mass in grams is equal to 6.02 times 10 to the 23rd atoms, or particles, or molecules, or ions. grams from the periodic table is equal to liters of gas? Yep, now I get it. All right, this right here, don't do that, is what I want you to use as the procedure for these problems. I want you to identify the given and the unknown. We're going to be circling the given and underlining the unknown. Identify the mole facts that apply from these 4 things. Hey, when you look up here, do you notice anything about the number that always goes with the mole?
1.
It's always
1.
1. It's always 1 mole. Please underline 1 mole on your paper. If you write if you're going to say mole, chances are 1 goes with it. Okay, here we go, the first way to do this. How many particles are equal to 4.75 moles of carbon? The given is the 4.75 moles. My unknown, what I would like to know, is particles. I don't know what it is, so I'm going to use an X instead of the number. The next thing I want you to do is write your given, write an equal sign, and then write your unknown. So right now, if you were solving this on your own, you would have written 4.75 moles equals X particles. You must write the number and the unit. The number and the unit. Why? You're not done with your number until it has some clothing on it. The clothing is the unit. The next thing you need to do is figure out the mole facts that go with it. This is how you do it. Whatever unit is on the top, immediately write it on the bottom. Then look up here for the number that corresponds. So if mole's on the top, mole's on the bottom, the number that goes with mole is 1. Particles on the top, particles on the bottom. The number that goes with particles is 6.02 times 10 to the 23rd. Then, you're ready to do your cross multiplying. I'm going to cross multiply these 2 things together. And this is how I'm going to use my calculator to do that. I'm going to type in 4.75, and then I'm going to multiply it by Avogadro's number. To put that in your calculator, you type 6.02 second EE 23. Your calculator must look like this when you put in Avogadro's number. Then all you have to do is press enter. Your answer is 2.8595 E24. The way you would write this on your paper would be 2.86 times 10 to the 24th. That's this part of the cross multiplication. This part of the cross multiplication equals 1x. So your answer is 2.86 times 10 to the 24th. Am I done? No. I need to write the unit that's next to the x, which is particles. Okay, now, moving on quickly. I had a typo here. This should say dioxide on the bottom, sorry. 46.8 grams of carbon dioxide is equivalent to how many moles of carbon dioxide? Here is my given. Here is my unknown. I write my given equals my unknown. I make sure that I have my units. Now I'm ready to make sure that these two units are the same on the top and the bottom. Grams on the top, grams on the bottom, moles on the top, mole on the bottom. Time to find some numbers. Looking up here, I got mole is 1. Grams, I need to find the molar mass of carbon dioxide. Carbon dioxide has a C and it has an O. How many? 1 C, 2 O's. Times the number on my periodic table, 12 and 16. 1 times 12 is 12, 2 times 16 is 32. Add that up, 44 is my answer. I'm now going to do my cross multiplying. 46.8 times 1 is 46.8. 44 times x is 44x. I would like x to be all by itself. In order to make 44 go away, I need to divide it, gone. If I divide one side, I have to divide the other side. This cancels out. 46.8 divided by 44 is 1.06 moles. Last one. How many grams are equivalent to 25.9 liters of CO2? Here is my given. Here is my unknown, given on top, unknown on the top next to it. My units must carry down, liters over liters, grams over grams. Go finding some numbers. I'm looking up here for liters. There it is, 22.4 liters. My grams from the periodic table, I've already done this math. Here it is right here. Cross multiplying. 25.9 times 44 is something that could be 1139.6 is equal to 22.4x. And when I put this in my calculator, this is what I get. 50.9 grams.